Yes, sir. Let's start.
Okay, good evening everyone. So today we are going to discuss the questions that has appeared in the GATE 2023. So let's start now. So typically for the gas dynamics, roughly there were 6 questions. One question came for the 1 marks and remaining 5 was for the 2 marks. So totally GD was for 11 marks. So let's start with the question number 1. So we had first question number 33. So their question was to find the ratio of speed of sound in hydrogen whose molecular weight was given and nitrogen whose molecular weight 28 was given at temperature 300 K and pressure 2 bar, and you are supposed to give an answer with a round of up to second digits. Okay, so as you know, speed of sound for isothermal process is C is equal to square root of RT, and since temperature is constant here, nothing to worry about that. So finally you need to figure out what is the value of R for hydrogen and nitrogen and just calculate the speed of sound for those two gases and you get your answer. So the gas constant R is given by the universal gas constant R bar divided by the molecular weight of the gas. So finally we are looking at unknown, which is ratio of R of hydrogen by R of nitrogen. So R of hydrogen is nothing but R bar by 2 because the molecular weight already 2 is given. Similarly, R of nitrogen is R bar by 28. So that turned out to be 14. And the formula for speed of sound, you just divide by the hydrogen and the nitrogen. R is the only variable which is going to change here. TT get cancelled out. So we can just cancel the temperature here. Then you end up with R of hydrogen with the R of nitrogen, which already you know that it's 14. So square root of 14 turned out to be 3.74. So a final answer would be 3.74. Okay, so question is pretty straightforward. I suppose less than 30 to 40 seconds you are supposed to give the answer for this question. Okay, so next we had a question of oblique shock wave. So for oblique shock wave, if you remember your
Sorry to interrupt. Sir, you can highlight
yes,
the question. Sir, while
yes, sir.
reading, please highlight the question, sir.
Yeah. So question number 37 was the question, second question from the gas dynamics, and it's based on the oblique shock wave. So for oblique shock wave, if you remember your theta beta m relation, this question was pretty straightforward. So the question was, a supersonic aircraft has an air intake ramp that can be rotated about the leading edge O, the lip of the intake, such that the shock from the leading edge meets the cowl tip. So this is the point where the cowl tip is located as shown in figure. Select the correct statement. You are supposed to choose all the statements that are correct as per the oblique shock wave theory when the flight Mach number m is increasing. So you are supposed to analyze what will happen when the free stream Mach number, which is supersonic, it increases. So let's go one by one and then we'll see which are the statements are correct or wrong. So for that, first thing you need is the theta beta m graph. If you remember this theta beta m graph, then the question is very simple. So first look at the point number A. What it says is, it is always possible to find the ramp setting angle theta r ramp, this is the theta ramp, such that shock still meets the cowl tip. So what it says is, whatever is the Mach number, you will have a possible theta at which the beta in such a way that the shock always fall on the cowl lip. Okay, that's really actually without even considering the theta beta graph also you can say it is wrong, because for no intake that situation is possible, but still for the sake of theory we'll do that exercise. So if your inlet Mach number is increasing, so if you look at this graph, And if you are holding the theta constant at a given theta, if Mach number increases, then beta actually reduces. Okay, now if the beta is reducing and you want to maintain the shock wave projecting at the cowl lip, you have to somehow increase the beta. How we can increase the beta? We are supposed to increase the theta. So for certain period, you can increase the theta so that beta also keep on increasing, but you can only increase the theta up to a level where theta become equals to beta shock. After that, if you further Mach number increases, you can't do anything. So the first statement is going to be wrong, because you cannot increase the theta indefinitely or the Mach number indefinitely. So always never possible. Next, if theta ramp is held fixed and shock angle beta will increase. So that's pretty straightforward. It is saying if you keep the theta constant and if you are increasing the Mach number, the beta supposed to reduce. So let's look at the statement. So as the Mach number increases, beta will reduce. Actually, it is right. So by mistake, I have put it wrong. Sorry about that. Oh, sorry, my mistake. They are saying beta will increase, but in reality, beta will decrease. So definitely this statement is wrong. Okay. Now look at the C. What it says, if M exceeded the critical value, it is not possible to find a ramp setting angle theta ramp such that shock still meets the cowl tip. Beta shock remain the same. That's of course actually true. If you increase the Mach number to a limit where your theta has become equal to cowl tip, the intake is fully closed, then you cannot maintain the beta shock further. So the statement is correct. And finally D, which says beta is less than sine of 1 by m. If you remember, the sine inverse of 1 by m is nothing but your Mach angle. Okay, and this is the weakest wave you can have, and we already discussed the limit of oblique shock wave is the mu, which is the Mach cone angle. So this statement also is true. Beta will always be greater than the Mach angle. So final answer C and D will be correct and A and B will be wrong. So you are supposed to choose the correct statement. So answer would be C and D. Okay. So let's go to the next question. Okay. So next question is question number 39. What it says is perfect gas stored in a large reservoir exhaust into the atmosphere through a convergent duct. The reservoir pressure is P naught and the temperature is T naught. The jet emerged from the nozzle at the choked condition where the average velocity U, Mach number M, pressure P, temperature T, and density rho. Now, if the reservoir pressure is increased, so they are increasing the reservoir pressure. Which of them is correct? So that we have to just find out. So this also very fundamental, no calculation required. You just need to know the pretty much some basics of here. So we'll just draw our old diagram where there is a reservoir and you have a P naught and T naught as a reservoir condition, and at exit, as you remember, we always denotes the exit as a E, and here you have a velocity, Mach number, pressure, temperature, and density. Now we have to find out what will happen to all these properties when total pressure of the reservoir is increased. Since they did not say anything about the total temperature, we are going to assume that total temperature remain constant. Okay, so now look at the condition. And one more thing you have to pay attention is, it is saying that the nozzle is choked. We don't have to figure out that part, already given. So when the nozzle is choked, the exit pressure is nothing but P star, the critical pressure. That is nothing but a constant multiplied by P naught. This constant actually depend upon the gamma. I'm not writing the formula here because we are just looking for the nature of the P, how whether it will increase or decrease. So the exit pressure is nothing but a constant multiplied by P naught. Exit velocity, since Mach number is 1, exit velocity will be given by square root of gamma RT star, and gamma is constant, R is constant. Once again, T star can be written as a constant into T naught. So finally, if you see, you can club all these three constants into one big constant and put C1 into square root of T naught. So exit velocity is nothing but a constant as a function of total temperature. Next is the exit temperature. Exit temperature will be T star, which is nothing but a constant with a multiplication of T naught. Finally, exit Mach number is always going to be 1 because it is convergent nozzle and choked. And if you want to look at the rho star you can rewrite as a P star by RT star, and 1 by R you can take it out separately because you know that it is going to be constant, and P star already we have derived that it is constant and a P naught, and T star will be constant multiplied by T naught. So finally combine all constant on together and finally a function of P naught. So in summary, if you are changing the P naught, if you are increasing the P naught and total temperature is constant, then your exit pressure is going to increase, velocity will remain constant, temperature will remain constant, Mach number will remain constant, and your density will increase. So now if you look at all the options available, we finally concluded that P and rho are only going to increase, rest of the parameter will remain constant. So from our calculation, C is supposed to be a correct answer. Okay, so let's go to the next one. Yeah, look like there are again a lot of Scramjet question this time. So next question is question number 41. So it says a Scramjet engine features an intake, isolator, combustor and nozzle as shown in the figure, and station 3 it is the combustor entry point, so combustion chamber is between 3 and 4 or anything after that, and air is calorifically perfect gas and with a specific heat ratio of gamma. Select the correct expression for the Mach number M3, Mach number at the intake of the combustion chamber to the combustor from the option given. So we know that free stream Mach number is M infinity, infinity and P infinity. So the Mach number at station 1 will be M infinity, and Mach number at station 3 we can write as a M3. So now we have to choose among these four which relation is correct, and until you derive it, there's no way of knowing which one is correct. So we are looking for a relation between M3 and M infinity. Okay, a very important point that you have to pay attention to this question. Yes, sir. Any questions, sir?
I think in last question, someone was saying it is MCQ. I'm sharing the question. Someone was saying it was a MCQ question, not MSQ question. Heist, can you again write your comment?
Okay, sir. I can't really see the chat here.
Yeah, I'll share you. Those comments are coming in YouTube. I'll share you the link of YouTube. Yeah.
Okay, sir. Let me finish this question. Then can we take up the question once for all?
Sure. Please. Yeah, continue,
okay.
Please. Thank you, sir.
Okay, so yeah, where I was. So we are looking for a relation between M3 and M infinity. So how to find the relation with M3 and infinity is you have to pay attention to this part. Assume stagnation enthalpy to be constant between station 1 and 3. So enthalpy is constant. H naught 1 is equals to H naught 3. And you know that H naught is nothing but CPT naught. So finally, what we have is, what is given is T naught 3 is equal to T naught 1. We will start from this relation and we'll finally see how. I have already marked the answer for you. So we'll see how to come from T naught 3 to T naught 1. Okay. So as you know that totals to static temperature relation with the Mach number is T naught equals to T 1 plus gamma minus 1 by 2 m square. So you can write this relation at both point, at the 1 as well as at the 3. So T naught 1 is equal to T infinity as a function of M infinity, and T naught 3 is equal to T3 M3. And we have already established, it is given that T0 1 is equal to T0 3. So you just put them both equal. Okay, and since you know that from the all four relation, you have to pay to that. See, you don't have to go to much complicated derivation. You just want to find out in which manner the A, B, C, D is given. You have all the four answer. You just look for the pattern here. So finally, if you look at all the four answer, M3 is on LH side and rest of the properties are on the RH side. So we will do the same thing. Once we expand the relation, we will try to keep the let me take the pen there. We'll try to keep the M3 on the one side and throw rest of the property on the other side. So you have a T infinity as it is, second term also as it is, then this T3 will go to the other side, so become minus T3, and gamma minus 1 into T3, this term, this will go into the denominator, and M3 square will remain here. So next we will send this T3 inside. So everything get divided by T3, T infinity by T3, gamma minus 1 by 2 M infinity square T3 by T infinity by T3 minus 1, and gamma minus 1 by 2 we can just reverse it. Now question is, how do you get all this idea quickly in the exam? Because in exam, best case scenario, you have a 30 to 40 second, and this whole derivation is supposed to be done in that time. So for that, you should take a hint from this question. See, if you look at the question everywhere, this is a ratio T infinity by T3, right? Everywhere this ratio is there. So you know that you need to have this ratio somewhere, and that can only be done if you divide the whole thing by T3. So we already got the ratio T infinity by T3. Okay, now I just pasted the relation there from the back side. Nothing, no change from this up to this point, it is same. And if you take the T infinity by T3 common out of these two terms, you have a 1 plus gamma minus 1 by 2 M infinity minus 1 will remain as it is, and 2 upon minus 1 by as it is, and the square will go other side, it becomes square root. And if you look at this relation, this is nothing but a B. So this question was really not that complicated, except you might get stuck in the derivation if you don't plan your timing and you don't take the hint from the question. You are supposed to take the hint from the answer available and then try to navigate your derivation in the given direction. Okay, so let's take the another question. We have just one more question, and after that we can take up the question. So next question is 44, and it says we have a one dimensional.
Just a moment.
Yes, sir.
Sir, please move back to 37 number question.
Yeah.
So they are saying B can't be the answer. It is MCQ, not MSQ, sir. Can you look into that?
It is MCQ, sir, not
MSQ. Like D, some students challenging, D is not the correct answer. Can you please look into back your relations?
No, not possible, sir. D has to be correct.
Please check, sir, once. Like one has done some argument, I'll share.
Not possible. The theoretically not. If required, theoretically if required, I can cancel the C, but I will hold the D.
Sir,
there are possibility I can say that D can be wrong by saying some argument. There are different version of it, but D is the absolute truth. It cannot be correct. It cannot be wrong.
See, the argument is someone said beta greater than Mach wave given was less.
See, question number D, part D says the Mach wave is always bigger than the beta. That is the meaning of D.
Okay.
So I'm not sure in any under circumstance this is theoretically not possible. A, B, C can be wrong if it is only a single question, like multiple choice question. Oh, sorry, multiple. Just to have one correct answer.
Yeah,
Then
then D,
definitely
as
D
per
has
you,
to be
D should
chosen.
be the answer. So C
If
can't be the answer. Means
I will
if
not choose the C, yes, I will choose the D only. Yes. But I thought that
also,
there are, see, but sir, if you look at the question number 37, it says select all correct statement. I'm not sure it's a MCQ. I really have a doubt on that.
so that means it kind of challenging the question kind of thing, right?
Dep
Okay.
Depend yes, if they deduct, because see, if you don't choose the D, anyhow you are giving the wrong answer, even if it is MCQ or MSQ, whatever you do. So you can't challenge the person who has not chosen D. He cannot challenge the question either as a MCQ or as a MSQ.
Okay.
So whoever forgot to mark the D, and they are saying that it was only MCQ, but since it is MSQ and you are supposed to mark D also, you will lose the marks.
Okay, sir. So we will discuss at the end again this question. I'm inviting some of the IGC students to counter their argument. Uh, yeah, so let's move to the question which you were discussing, I think 44 question.
Yeah, just a second, last question. Okay, so here we have a combination of 1D CD nozzle flow and the Rayleigh flow. They have mixed two flow. So question says, we have one dimension inviscid supersonic flow in a divergent duct with a heat addition as shown in which of the following statements are always true. So see, whenever sir I see this statements S, it means there are multiple options which are correct. So they have to pay attention a little bit to this S written in the statements. Okay, so there you have a M1 T1 P1 and it says it's a supersonic. So M1 is actually greater than 1. So now we have to make sure that they're always true. See that we have to pay attention to the keyword always. Doesn't matter what happened, they should always be true. So I'll go backward so that it's easier to eliminate the options. See, in the gate, the best strategy is elimination. You start with what you know and start eliminating correct parameter, you end up with the limited choice. Then you can make an selection. So option D is the stagnation temperature. So T02 is here and T01 is here. Since you are adding the heat, so definitely no matter what is the amount of heat you are adding, T02 will always be greater than T1. So you can easily mark the D, no question. Next, stagnation pressure B. B also is kind of clear that stagnation pressure P1 is greater than P2. So P1 not here and P2 not here. So as you know, the Rayleigh flow, the total pressure drops. In CD nozzle, it's remain constant, but in Rayleigh flow, it does drop. So definitely, even if you are adding very small of Q in, the total pressure is going to drop and your B will be correct under all circumstances. Okay, next, A part, Mach number M2 is greater than M1. For this, it's a debatable because since it's a divergent duct, as per the CD nozzle, M2 will increase, but as per the Rayleigh flow, M2 will decrease. So it will depend upon what is the Q in and what is the area ratio. So it's not always it will increase and it's not always it will decrease. So you cannot mark A because they are asking always. Similarly, static pressure. As per the CD nozzle, static pressure will drop, but as per the Rayleigh flow, static pressure will increase. So again, C option is sometime true, sometime false. So we should always cross the C also. So finally, the question number 44, I guess B and D should be chosen as a correct statement. Okay. So finally, we have a last question, even though it's really a gas dynamics, not gas dynamics question, kind of in a aerodynamics, but since it was there in the list, I just marked the answer. So they're asking critical Mach number and direct divergence Mach number relation. So if you guys remember, M critical and MDD are nothing but the streamline Mach number at which, if there is a shock or Mach number crosses 1 or reaches 1 on the aerofoil somewhere, you call it as a M critical, and M drag divergence is the Mach number where your drag sharply start to rise. Okay, this is MDD. So first M critical comes, then MDD comes, and then finally you have a Mach 1. Okay, so among this, if I have to choose, definitely drag divergence is always bigger than critical. M critical is less than 1. M drag divergence also is less than 1. Mach M critical is not greater than 1. So you have A, B, C correct, and D is wrong. So A, B, and C, these should be your choice. Okay, so with this we have discussed all the question. So now actually we can start taking up the question. I don't have a question directly with me, but Dinesh sir, can you just post the question so that we can start discussing?
Definitely, sir. So first, let's find again, sir. Please explain, word by word, 37 number question, because the argument again, a new argument is coming, which says make wave always lesser than beta. Beta always lies between normal shock and make wave.
Just a minute, sir.
Yeah, sure, sir. In chat, I shared. In mobile, you can see chat, sir.
Let me see. Sometime possible I myself will be wrong. So the oblique shock limit is pi by 2 is the maximum limit. Yeah, correct, sir. Answer actually option D is wrong. It's other way around. Okay. Beta should be greater than sine inverse of 1 by m. That's right, sir, actually. So option C is only finally left over. That's correct. Beta is the sign is opposite. Actually, I misunderstood this part. Beta limit is between pi by 2 and sine inverse 1 by mu. So beta has to be always greater than the Mach angle. That's correct. So finally, actually, even though it says select the correct statement, there's only actually one statement correct. So even if you choose more than one, definitely you are choosing the wrong statement. So that's correct actually. Whoever said that part D, that's correct.
So you please mark D as a wrong, sir.
Yes, sir. D is the wrong answer. Yes, sir. I already marked, sir.
Yeah, thank you, sir. So, yeah. Guys, concluding remarks, sir. First time I'm seeing so many questions from GD. I think 9 questions. 9
it's almost
marks.
Around 11% of the total marks.
Yes. So, yeah. So really, this year paper was, sir, orthodox. Like usually GD they ask 5 to 6 marks and they ask more fluid mechanics. This time, ideally, yes. I think only 1 or 2 questions from fluid mechanics basics.
But good thing, sir. No numerical this time.
Yes. So, but these kind of questions, sir, many people do mistakes, sir. Specifically numerical.
Very tricky, sir. Very tricky.
Yeah. So, thank you guys for joining session. Any question, guys? Now, floor is open in any of the question. Anupam, any question? Because we need to move next session also after this. Sir, you can go to last slide. Thank you slide or more contact slides. You can move to that. Anybody, any question? Sameem, Raviteja, any question, guys? So all is clear. Anupam, out of 9, right? Or out of 11? What you say? Shamim, guys, can you write your marks? Guys, who all have attended this session, can you write marks? Anupam 8. Others? Others quickly write the marks. Ravi Teja, how much marks? Samim. Praveen. Okay, sir. So done, sir. We'll wind up. We'll wind up, sir. So thank you guys for this session. We'll be moving to next session, which is for general aptitude. Thank you guys.